In today's lecture, we'll be discussing about the time-dependent perturbation theory for mini states. So consider you have a Hamiltonian H0 which acts on a wave function psi1. It gives you E1 psi1, and if it acts on wave function psi2, it gives you E2 psi2. And here I'm considering psi1 to be ket1 and psi2 to be ket2. It's just like you have a name and then you have nickname as well, but it's the same person, but you have a real name as well as a nickname. Just like that, here the nickname of psi1 is ket1. It doesn't change the physical meaning to it. And now I'm considering a state where this is perturbation. So what perturbation really means is like a small push. So you are swinging in a swing and then someone from the back pushes you, and then there's an extra speed to it, or there's a change from the normal state. That's what is called as perturbation. So we are considering there's a perturbation happening. So the total perturbation equation is H is equal to H0 plus H1 of t, where H0, this is the unperturbed state and this is the perturbed state, and this is the total Hamiltonian. So here the wave function is time dependent since the perturbed state is time dependent. That's the reason why wave function is time dependent. So why the wave function is time dependent? Since the perturbed state Hamiltonian is time dependent, and because of which it makes to change the state between ket1 and ket2. So there will be change of state between ket1 and ket2. That's the reason why wave function is time dependent. So you can write the final formula for like a solution for the wave function to be a1 of t e raised to I1 t by h cross ket1 plus a2 of t e raised to minus I e2 t by h cross ket2. And then this is a Schrodinger picture equation, that is IH cross. This is a Schrodinger equation, okay. IH cross dou psi by dou t is equal to h psi. What you're going to do is just apply. So yeah, you have to just substitute psi here and here and just solve it simultaneously. So in order to solve it like in a quick manner, I'm just going to separate LHS and RHS. So I'll first solve the LHS part and then solve the RHS part and then simultaneously solve it. So I'll just write LHS equal to RHS and solve it, okay. So first step is I'm going to take the LHS part, which is IH cross dou by dou t. I'll just write the whole psi part, that is a1 of t e raised to minus I e1 t by h cross psi1 plus a2 of t e raised to minus I e2 t divided by h cross ket2. Now what you're going to do is differentiate. So you have to differentiate. So this will also have, and this one is there. Then product rule is happening because there's a product rule. Okay, so you have to totally, after differentiation, there will be 4 terms, 2 for this term, 2 for this term, and then you have to add it. So it will be like this. So it's just a normal differentiation. You would keep this constant and differentiate this, you will get this term. Then you keep this term constant, differentiate this, you will get a dot, then that is this one. Just like that, keep this constant, differentiate this, you will get this one. Keep this constant, differentiate this, you will get this one. That's it. Normal simple differentiation. Next, what you have to do is you will just solve it. You will just bring the outside EH cross this one to inside and multiply the normal simple calculation. Yeah, so what we did now is that I just opened the bracket. So I into I is minus and there's a minus inside, so it became plus. So just bring all the IH cross inside and group it, and then there's 2 IH cross terms. Here there's an IH cross and here also IH cross. I grouped it outside, so I get an IH cross here, and the terms without IH cross I wrote it separately. So this is a simple math I just did, and I'll give this equation 6. So this is not equation 6, so this is equation 6. Just simple math. So this is LHS equation. Now what you're going to do is solve for RHS. RHS, what was the RHS term? RHS was H psi. So it's simple. You just have to multiply H psi, that is the H0 plus H of t into the whole wave function, that is H1a, sorry, this one. Yeah, so this is the RHS. Now as usual, you just have to multiply inside and solve it. So you can pause the video and open the bracket and see it yourself, the solution, if it's matching with mine. So I'll just give you a brief idea. You just have to multiply into this, this into this. You will get 4 terms. Just multiply, just see and cross check with my answer. Okay, so now you will get it like this. So if you remember earlier, in the first equation we wrote as that H naught of ket1 can be written as E ket1. Same thing, H naught of ket2 can be written as E2, E ket2. So you can just rewrite it and write the formula again. So you will get it as, so finally this is the equation you get. This is the LHS, the solved LHS, and this is the RHS. So I'll just copy paste it here. I'll just take this full equation and rewrite it, otherwise it will be very hard to see. So yeah, what I did here is that this was the equation for the RHS and this is the equation for LHS. What you're going to do next is you're substituting LHS is equal to RHS. You just have to equate it and solve it. So that's the 6th step. So you can see, you can cancel off any common terms here. If you see here, there is A2, E2, the whole term is here. You can cancel that off. And also the same thing goes there. This one also gets cancelled. So these two terms cancels off and you'll get 4 terms left. So I'll just rewrite those formula. I hope you understood what I did. I just had to write LHS is equal to RHS, which is equation 6 is equal to equation 7, and cancel off the common terms. That's all what I did right now. And I'll rewrite the equation, the whole equation, which is not cancelled. The equation which is not cancelled, I'll rewrite it. Okay, so finally you will get these terms. This is the final equation, the non-cancelled terms. So to solve this equation, what you're going to do next is we'll multiply with ket1 star, psi1 star, and then integrate, or else or maybe a simpler calculation. What we can do is we just have to multiply by bra1. Okay, it's just simple math. You just have to multiply with bra1 and solve it. So you can pause the video and solve it. So you get like this, and in this term, this is an operator, so you just can't multiply, you can't do this operation where this is 1, and this thing rule cannot be used here because h dash of t is an operator, so you can do this. But here we can do this. This term will become 1 and this term becomes 0. The whole term becomes 0. So rewriting that, I'll get it as this. Let us assume a molecule is sitting in the ground state. And then according to equation 1, okay, so so this is equation, I lost count. So maybe, yeah, so this is equation 8 and this is equation 9. Yeah, so here what you have to understand is that ket1, that's ground state. Ket2 is excited state. So if ket1 and ket1, this means there's no transition. It's there in the ground state itself. The transition is happening in the ground state. So consider there's a molecule gets excited and it falls in the ground state itself. There's no transition. When will there be a transition? When a molecule is excited and goes to the another state. So in this state, there's no transition. Whereas in this state, there's a transition between ket2 state and ket1 state. Hence, we can neglect this state because there's no transition and write only these 2 states. So I'll rewrite and give you the final formula. So successfully we found the equation for A1. So A1 dot. Now you have to find for A2 dot. In order to find for that, you have to revisit this equation, and here what we did was multiply with bra of 1. Now to this equation 8, you have to multiply with bra of 2 to get A2 dot. Okay, so do the same thing, follow the same steps and and I hope you'll get this equation. I'll just write the final formula. Just do it by yourself and cross check. Yeah, so finally you will get this equation. Maybe to make it more beautiful, you can divide this IH cross this side and make it into a more simplifier, and yeah, you can take all these terms to the other side and make it beautiful. So maybe I can do that and write the final formula to be. So finally you'll get this equation, and we can imply that the time dependence of A1 depends on A2 and vice versa. Hence, the pair of equations are called the coupled equations. And it means that A1 changes with respect to A2 and vice versa. And even the phase, they're out of phase, which means that A1, if A1 goes up, A2 comes down. So, and vice versa, like A2 goes up, A1 comes down. And that's the implications we can take. So, first one, they are coupled together. Like A1 changes with respect to A2 and they're out of phase. If A1 goes up, the A2 comes down. So these two are the implications of this equation. Oh yeah, and also to more simplify this, we can do something else as well. We can write, delta E is equal to E2 minus E1, right? Which is also equal to H cross omega. So instead of this term, we can write it as H cross omega, and H cross gets cancelled. So I can write it as omega 2-1 of t, because 2-1 means E2 minus E1. That's why I wrote it as 2-1. Same thing, I can write it here, omega 2-1 of t. I hope you understood how. So it was initially E2 minus E1, and by H cross I substituted and I got this equation. Okay, fine. So this is the final equation. While cross checking, just cross check if this is correct. If this is A1, this is A2, this is A2, this is A1. So this is a correct final equation.